Hi, this video we're going to continue on the discussion of resultant force and in two dimension. Instead of using triangular rule, we're introducing a brand new technique. And this technique, however, is actually the most general rule we're using. And you might likely find out later on during this course, you will actually use this rule way more often than triangular rule. So this rule, if you give a name, will be decompose. Let's see how that's done. So here, I invite you to look at the slides here, a force F. So this is one single force, just one F. And we're learning about concept, how we're going to decompose, basically break up this one single force to two rectangular components. One is called rectangular, one is on x-axis, another one is on y-axis. Okay, so we need to break up this F, red F, to F1, Fx, and Fy. And if we were to do that, and we go ahead and draw this rectangle. So this force is going to be the diagonal of this rectangle. And this projected to x direction is right here, Fx. Project to the y, this length will be Fy. Well, how do we find Fx? This is a right triangle. Using the right triangle, because we already know Fx is going to be F times cosine theta, or because this is adjacent, right? Adjacent, cosine theta is adjacent over hypotenuse. Now let's look at y. Y, if this angle is theta, we already know this angle will be theta as well. And opposite to this angle will be Fy. Opposite, we're using sine theta. So we know sine theta of this angle will be y over hypotenuse F. So knowing that, we already know Fy will be F times sine theta. So this is going to be, you're going to become very efficient, figure this out. That's a must learn rule. It's a skill you have to master basically in statics, how to decompose a force. And I want to do this very quickly. The rule of thumb is this force here is going to be your hypotenuse, and your x and y, which is going to be cosine or sine, very simple. If this one you're solving is going to be adjacent to this angle, you're going to use cosine theta. If this you're solving is opposite to this angle, it's going to be sine theta. Okay, so knowing that, and you already also know this angle, if you were to solve it, tangent theta is opposite over adjacent. Opposite is Fy, adjacent is Fx. So that's tangent theta. Again, using Pythagorean Theorem here, you also know this hypotenuse is going to be Fx squared plus this is Fy, right? Because you move this line to this one, it will be Fy square and take a square root. Okay, so simple stuff, but that's a must learn rule. And here is a quick review. Just a little trigonometry basics. Apply only to right triangle. Why? Because this is a rectangle. Okay, and this is Pythagorean Theorem. Again, this only applies for the triangle. All right, now knowing that, we're going to look at in terms of finding resultant force using decomposing method. We already know how to decompose. Now let's think about it. If a problem has like three or more forces on a particle, then how do we solve it? We're going to decompose. So the rectangular components of the resultant can be obtained by adding all those each given forces component. So basically here is, if I can find, if there were three forces, I found the x component for each one of them, and I add them up. That's going to be the summation of forces at x. Same thing, finding the y component of each one of the three forces, then sum them up, sigma here. Then you get summation of forces at y. And now, then go back to thinking about this. If you already know x, summation of x and summation of y, can you find a resultant? Yes, we can. We're going to use this Pythagorean theorem, right? So this resultant magnitude will be using this equation, rx squared plus ry squared, take a square root, Pythagorean. And that's a magnitude. How about direction? Then go back to here. If you know summation of fx, summation of y, and you know the direction is defined from x-axis counterclockwise to this force right here, which is your theta. And this theta, how do we define this angle? We already did. Opposite over adjacent, because this is a rectangle. It's a right triangle here. So it's Fy, summation of all the forces at y over Fx. That's how this equation comes about. And so those two important equations give us ways to find the magnitude and give us the way to find the direction. All right, now let's look at this one, this slide. For example, here you have three forces. They are concurrent, which means they apply at the same point here. And in order to find the resultant of those three forces, we're going to use this new decomposed method. First step we are going to do is decompose those three forces individually. So F1, for example, decompose to Fx and F1. You have F1x, F1y. That's how you decompose this force. F2, the same way. However, you realize F2 here, since it's going upward and going to the left, so your F2x is pulling to the left, okay? And F3, if you were decompose, it's going to be pulling to the right for x direction and downward, okay? So it's got a negative y-axis since it's downward, F3y. So now you have all those forces decomposed. Now what do we do? So you have Fyx, F2x, and F3x. You're going to add them up together. When you add them together, you have to consider direction. For example, F1, F3x, they're both positive because why? They're at a positive x-axis. However, F2 is pulling to the left, so make sure that's going to be minus F2x, and that's very important. If we don't consider the sign, the answers would be all incorrect. So pay attention to signs. Same thing for y direction. When you add all those resultant, when you're trying to get resultant at a y-axis, you're going to add F1y and F2y together. They're both pulling upwards, so they will be positive. However, realize what F3y is going downward, so that's going to be negative. Okay? So you add all those numbers together, sum of those together, that's going to give you FR, resultant at y direction. And when you have those two numbers now, then we're going to use those two equations you just learned to find resultant. So Pythagorean theorem give you the magnitude, and inverse tangent of Ry over Rx going to give you the direction, the angle. So that's for this. And here I want to introduce the I and j. Okay, so we use unit vector I and j to designate x and y axis. So for example here, for this one you have fx and fy. Those are x component and a y component. And you can write down in a vector form. So fxi, that's x component, plus fyj. Okay? So here it's again wrap up what we just did. Step 1, resolve each force into component. Step 2 is add all the x component together, and then add all the y component together. So then you are going to finding the magnitude and the angle using those two equations. So an example of them is you decompose f1, you can write down in a vector form, which is using unit vector I for x-axis, j for y-axis. So you write down as f1xi, f1ij, 1yj, and realize here I for f2x is negative because it's pulling to the left, okay? And then let's look at f3y. This is going downward, so it would be negative that number, so negative f3. Then you combine all the x terms, all the I terms, and combine all the y terms, which is j term, that together you can find the resultant force on that. Once you have those two, then you can use your formula, Pythagorean Theorem, and the inverse tangent y over x, you get your direction. All right, so that is the introduction of using decompose method to find the 2D resultant. I'll see you next time to look at an example. Bye.